In this video, you will learn how to solve a literal equation. A literal equation is an equation that uses at least two letters as variables, and you can solve any variable in terms of for the other variables. In the first example, it says solve each equation for the indicated variable. In the first example, it says that you are solving for x. Now, in order to get x by itself, we have to get rid of r plus x, or plus k, right here. The opposite of adding k would be subtracting k. So if I were to subtract k from both sides, u minus k aren't like terms, so I'm going to leave them as u minus k equals x. And that's our final answer. For the next one, we are solving for x. And in order to get rid of the m that's in front of that x, since m is in front of the x, think of it like m times x. And the opposite of multiplying is dividing. So we would divide both sides by m. So we get our answer is z over m equals x. For the next example, you want to solve for a. In order to get a by itself, we have to get rid of this plus c. And the opposite of adding c is subtracting c. So you would subtract c from both sides, and it's going to become a equals, in this case, the c can't combine with any of those other terms. So I'm going to leave it as d minus r minus c. In our next example, it's asking you to solve for x. Now this x is over here by itself. In order to think of this, we can think of this as x times k. In order to get rid of that k, the opposite of multiplying is dividing. So you would divide both sides by k. So it becomes x equals, and the other side is going to stay exactly as is. So it'll stay as v plus w over k. For the next example, you want to solve for a. So in order to get the a by itself, we first need to move the b over, just like if we were solving an equation. So I would subtract b from both sides to get u minus b equals negative ka. And then to finish getting this a by itself, we have to get rid of this minus k. And since it's written in this way, this is really can be thought of as it's like negative k times a. So we're going to divide both sides by negative k. And the left side will stay exactly as is. So it becomes u minus b divided by negative k equals a. In our last example on this page, in order to solve for x, we first need to clear the fraction. And in order to do that, we're going to multiply both sides by y, because the opposite of dividing by y is multiplying. So it becomes y times u equals kx. And now to get rid of the k that's in front of the x, since this is multiplying, you would divide. So we would divide both sides by k to get yu over k equals x as our final answer. Now we're going to do more examples that involve more numbers, but still more than one variable. In our first example, if we were to solve for x, in order to get x by itself, we have to get rid of the 8 that's in front. So you would divide both sides by 8. And g over 8 is going to stay exactly as is, and it equals x. For the next one, in order to get a by itself, we first have to get rid of the 3. So you would subtract 3 from both sides. So it becomes u minus 3 equals 4a. And then to get rid of the 4 in front of the a, since that's multiplying, the opposite of multiplying is dividing. So you would divide both sides by 4 to get u minus 3 over 4 equals a as your final answer. For the last one, in order to solve for a, we first have to move that 4c over. So you would subtract 4c from both sides. So So you get 3a equals 4 minus 4c. And then to get rid of the 3 that's in front of the a, you would divide both sides by 3. So divide both sides by 3 to get a equals 4 minus 4c over 3. In the last example, it's asking you to solve for a. In order to get a by itself, we first need to move over that minus 3. So you're going to add 3 to both sides. So you get z plus 3 equals 3a plus 3b. Now we need to move this 3b. So in order to do that, you would subtract 3b from both sides. So you get z plus 3 minus 3b equals 3a. And lastly, to get rid of the 3 that's in front of the a, divide both sides by 3. So you get z plus 3 minus 3b divided by 3 equals a as your final answer.